Hello students, my name is Mahesh Kohli and today we are going to discuss a very important topic and very interesting topic that is from the circulatory system and that is actually a condition known as erythroblastosis foetalis. First of all, I would like to talk about the meaning of the word erythroblastosis foetalis. So in language of biology, foetalis actually means the killing or death of the fetus, demise of the fetus. Why is the fetus dying? Fetus is dying because reason is here erythroblastosis. Blastosis means degradation of erythro means erythrocytes, that is RBCs. So RBCs coagulate and fetus dies because of the coagulation of RBCs. That is what this condition means. Now the question arises that why does the fetus die? What is the reason of the death of the fetus? The answer lies in a background knowledge of RH factor. Now because you have already studied about the RH factor, I will just quote the background context that you must have been told that RH factor is actually a glycoprotein which was first identified in the RBCs of the rhesus monkey, from which the name is coming RH, rhesus. So this rhesus monkey had this factor on its RBCs, and because rhesus monkey is an old world monkey and we share like ancestors, or we share a evolutionary relationship with old world monkeys. So scientists wondered that if this factor is present in the rhesus monkey, it might be present in the humans as well. And what they thought came to be true. When they searched, when they analyzed or researched on the human blood, they found it. They found that this factor is also present in the human blood. So since the name has not been changed, it is yet called as the RH factor, the rhesus monkey factor. It is also present in the human blood. And now on the basis of this, we can categorize the blood groups into two groups, like one which have this RH factor and another group which does not have this RH factor. Whereas supposedly those which have this RH factor are termed as RH positive. And to tell that if they are RH positive or negative, we just donate a sign of positive plus sign above their blood group. Supposedly, if someone has a blood group A and it also has RH antigen, we say he has blood group A positive, A plus. And that A plus or positive means that he has or she has whatever the RH factor on its RBCs. And if in case it is absent, which is rare case but less probability, but still in the nature. So if it does not have RH, if someone doesn't have this RH factor, we say that it has we denote the sign negative. So someone of the A category not having the RH factor would be termed as A negative. Similarly, O positive, O negative, B positive, B negative, AB positive and AB negative. So we have this kind of the blood groups, where plus minus is denoting the presence and the absence of RH factor respectively. As simple as that. Now, this is one concept. Second concept is that supposedly there is a person who is negative for RH antigen. So if you are negative, you do not have the RH factor, and supposedly this person, just put it up an example, that Mr. X does not had a blood group A negative, okay, and now we exposed this person with blood group A negative with a positive blood, let's say A positive. Now the RBCs of the donor will have RBCs with a RH antigen, and this Mr. X does not have that RH antigen. So when this RBCs from the donor come to Mr. X, the Mr. X body will see this Rh antigen as a foreign particle, as a foreign glycoprotein. As if the entire cell would be observed as foreign because he does not know. I don't know what is this Rh. I have never seen this Rh. I don't know how this Rh, right? So as it occurs in other diseases, supposedly a bacteria comes to your body, it appears to be a foreign particle. What does your body do? It generates the antibodies. It gives an immune response against that bacteria. So similarly, when this Rh antigen is appeared to be foreign material, our body initiates an antibody response, the humoral response, the immune response. But because it takes quite much of time, so not much difference is made, not much destruction is done, and if it's a first time exposure, it will not cause that much of, or it will not cause any significant damage, because making antibodies, giving an immune response takes time. Okay, but supposedly this was the first encounter. Okay, blood, positive kind of blood came in. It got like, now there was not a bit much of problem, not much kind of an issue, but if there is a second encounter, if again this positive kind of a blood did come to Mr. X, now Mr. X had a previous exposure, now Mr. X has the antibodies generated. Now Mr. X will make a significant attack on this RBCs having this Rh antigen. The attack would happen in the first case also, but it would not have been that significant. But the secondary response is always faster, the secondary response is always stronger. So the second response against the Rh positive blood from an Rh negative blood would be quite significant and may cause the death of the recipient. That much stronger. So on this concept only is based the concept of erythroblastosis foetalis. Now what happens is, I'll let you know that supposedly there is a female, okay, there's a female who's pregnant. This is a female, the mother who's pregnant, okay, and let's assume that the mother has blood group Rh negative, and that's quite possible, okay. Now, and by chance the fetus has, this is the fetus developing inside the womb of the mother, and the fetus has blood group Rh positive, okay. Now this is again possible, okay, because Rh positive is a dominant gene, so this is quite possible that mother may have Rh negative blood group, but still the fetus has the Rh positive blood group, okay, because what blood fetus is going to have is not just dependent on the mother but on the father as well, okay. Now what will happen now? Now you should just think it out, what could happen. Now one way to think is that fetus has this Rh positive blood, okay. Now fetal blood will move to the maternal blood, and maternal body will get to know that this is Rh positive. There is something we haven't seen. We should attack it. We should make antibodies, and the mother will make antibodies, and there is an ample of time because fetus is still developing, is a gestation period of 9 months. So there's ample of time. The mother will make antibodies against this positive blood, and those antibodies will get into the fetal blood circulation and kill the fetus. Okay? Now, this is not going to happen. This is not going to happen. Why? I'll tell you the reason. Because the fetal blood is well separated with the maternal blood because of a tissue, or you can also call it an kind of an organ, that is placenta. So placenta separates the, here we have, let's say, the maternal blood, and here we have the fetal blood. So there is a well separation of the maternal and the fetal blood, so they do not get mixed. No RBCs from here moves to here, neither RBCs from here moves to here. There is no movement of RBCs. Yeah, the oxygen may diffuse, the CO2 may diffuse, the ammonia may diffuse, things may diffuse, the antibodies may move, okay, but there is no movement of the RBCs. So fetal RBCs are not exposed to the maternal blood. Maternal blood does not know that what is Rh positive, so they do not produce any kind of antibodies. Nothing happens to the fetus. Fetus survives, no issues. But condition that this mother should have never been in the, we assume that this mother has never been exposed to Rh positive blood. Okay, if that would have been the case, if mother would have been previously exposed, okay, somewhere in her life, just before pregnancy, to with an Rh positive blood, then this mother would have been generating the anti-Rh antibodies. By supposingly that she might have an accident, and by chance she would have been given a positive kind of a blood. So she would have been exposed to the positive antigen, and she would have been making antibodies, and then those antibodies would have diffused to the placenta and caused death to the fetus, would have coagulated the fetal blood, because antibodies can move, specifically if they're IgG, okay, and anti-Rh antibodies are IgG, so they IgG type, so they can move through the placenta and they can coagulate the fetal blood. But here we are assuming that mother has no primitive exposure to the Rh positive blood. We are assuming that. So in this case, mother does not have any antibodies. So nothing happens to the fetus. Fetus survives, no issues. Okay, so this pregnancy is completed, the gestation period is completed, and the fetus has moved out. Okay, so fetus is delivered. There has been parturition, but now during parturition, this placenta is also removed. It's known as after birth. Now, when this placenta is getting removed, that is the time when a little fetal blood enters maternal circulation. And when this fetal blood enters maternal circulation, now maternal circulation is exposed to the Rh positive blood. And what would mother do? What will maternal body do? Maternal body will generate antibodies against that blood, against that Rh factor. So now what will happen? The mother still remains Rh negative because nothing will happen to the blood group, but now she has something known as anti-Rh antibodies. What antibodies? Anti-Rh antibodies. Clear? And why have they come? Because of the little exposure to fetal blood. Okay? Fine? Okay. Now what will happen? Now what happens? There is another pregnancy by chance. We are just assuming it. There has been cases. There is another pregnancy. And by chance again the fetus is Rh positive. But the body of the mother has changed. How? Earlier she was only Rh negative. She's still Rh negative, but now she has got the antibodies. Which antibodies? Anti-Rh antibodies. And where have these antibodies come from? From the previous exposure. So earlier, mother was Rh negative but without any anti-Rh antibodies. But now mother is Rh negative again, but with the antibodies. Now what will happen? These antibodies will cross the placental barrier, will cross the placenta, and they can, because they are IgG type, so they will cross the placenta, they move to the fetus and they will coagulate fetal blood. They will coagulate fetal blood, and what happens? Fetus dies. Fetus dies. And this thing, death of the fetus because of the coagulation of blood, this is Erythroblastosis Foetalis. And when does it happen? It happens in the second pregnancy with Rh positive blood. Condition is the first pregnancy should also be from the Rh positive fetus. So second consecutive pregnancy from Rh positive fetus will cause the death of Rh positive fetus because of the antibody generated by the mother from the exposure of the previous delivery of the Rh positive fetus. That is Erythroblastosis Foetalis. I'll make you write down in your notes. Okay, don't worry on that. Just understand the concept. Okay, so that is about the concept of the Erythroblastosis Foetalis. Now, things don't end here. Ask yourself question. This is what is happening. How can I prevent it? How can I prevent it? Now, whenever you always think about prevention, you should always go how the disease is occurring. If you analyze in your mind that how the disease is occurring, you will always come to the answer, how can you prevent it? Now, let's go back. Okay, so problem is these antibodies, right? The problem is these antibodies. Am I right? Yeah? Hello? Yeah, right. So the problem is these antibodies. Now, if somehow we cannot stop antibodies moving to the placenta. That's not possible. That's a very tough thing to do. That's not easy and not possible even. Might be possible somewhat later, but not right now. It's not possible. But can we stop antibodies from forming? If we stop it here or here, we cannot stop the exposure of the blood. A little blood will get exposed. That is true. So we cannot stop here. We have to stop after this. Look, there can be an exposure, but after the exposure, the antibody should not form. So this is the point where we can stop, where we can put an inhibition. And how can we do that? Now there is a very simple solution. I'll tell you 2 to 3 solutions, but very important solution is what we do is we use anti-Rh antibodies just after the first delivery. There was a delivery, there was a little blood. We ourselves give anti-Rh antibodies. Now this will sound quite weird, but we want anti-Rh antibodies to not form and we are giving anti-Rh antibodies. Now what is happening? Just listen, very important, very interesting. Anti-Rh antibodies, what we'll do is, as soon as there was a delivery, we know that some fetal blood with Rh positive antigen might have come. We'll give some antibodies. These antibodies will degrade this blood. So before the fetal blood gives a strong exposure to the maternal body, we give preformed antibodies and these go and bind to the Rh positive blood and coagulate or degrade this blood, which is then engulfed by macrophages. So everything is clear. There is no more Rh positive blood, and if there is no more Rh positive blood, mother is not completely exposed to Rh positive blood and mother does not produce anti-Rh antibodies. So the simple solution is giving anti-Rh antibodies just after the exposure. Clear? This is one of the solutions given in NCERT, and NCERT directly quotes this solution. What can be other solutions? Other solutions can be, because we do not want antibodies to be formed, we can give some immunosuppressive drugs. Now immunosuppressive drug will suppress the immunity of the mother and the antibodies won't be formed or will be formed in a lesser number. Right? What third thing can be done? By chance, let's say these antibodies are formed. Then what we can do is we can do another step. Again, this is not quoted in NCERT, but still there is another idea. What we do is we give antibodies complementary to these antibodies. You can say, you can give anti-RH antibodies. So if we give antibodies, these are the anti-RH antibodies. Against these antibodies, we give another antibodies. So those are known as anti-RH antibodies. So that we can give against these antibodies. So these antibodies will bind to the antibody given by us. They will bind and they will not further bind to the blood of the fetus. That is another solution. But you should always remember this solution because this is the one which is quoted in NCER. Okay. Cool. Fine. So that is all about the erythroblastosis foetalis, and that's all about this topic. Any other further doubts you can ask me later. Thank you very much. Have a nice day ahead.